So hello friends, welcome back to my YouTube channel. Today I will be explaining the linearization topic, which is important for exam. It will come for 2 marks. So let's start. If f is differentiable at x is equals to 0, then approximating function Lx is equals to fa plus f dash a bracket x minus a. So this is the formula of linearization. So in the linearization of function at a, the approximation fx belongs to Lx. So of f and L is the standard linear approximation of f at a. The point x is equals to a is the center of the linearization. So let's begin to the examples. So let's see. Find the linearization of fx is equals to root under 1 plus x at x is equals to 3. So we have the function fx is equals to root under 1 plus x at, so we will be first finding function 3. So we have x is equals to 3, that means a. So f3 is equals to root under 1 plus, we will put the value of x here, so 3. So root under 4 is equals to 2. So again f dash function is equals to 4. So first derivative of function, so it will come 1 by 2, 1 plus x को power minus 1 by 2, so it become 1 by 2, 1 plus x को value 3, so power minus 1 by 2 gives 1 by 4. So we have the formula Lx is equals to function a plus function first derivative of function a bracket x minus a. So we will put the values and we will get x plus 5 by 4. So move on to the next problem. So we have the next problem. Find the linearization of function cos x at x is equals to pi by 2. So fx is equals to cos x, f pi by 2 is equals to cos pi by 2. So we get 0, cos 90, 0. So first derivative of function f pi by 2 is equals to minus sin pi by 2. So we will get minus 1 by 2. And then applying the linearization formula, Lx is equals to function pi by 2 plus first derivative of function pi by 2 bracket x minus pi by 2. So putting the value of the function, we will get so 0 minus 1 bracket x minus pi by 2. So this multiplies minus x and minus minus plus pi by 2. So we will get minus 2x plus pi by 2. So let's start the problem. So we have the function this. So solution, given function is this. So we have function at a. What we have is equals to, put the value of a, so 1.3. so first of all 1.3, so putting the value 1.3 plus 1 we will get, so 1.3 divided by 1.3 plus 1, so we will get 0.56. so first derivative of function, so we will apply the u by v derivative. So we will get first this x plus 1, so this derivative 1, so minus this this becomes outer side, so it becomes 1. So here x dot derivative of this becomes minus 1 x what here plus x plus 1 को power minus 2 and derivative of x becomes 1, so divided by x plus 1 को whole square. So we will put the value and we will get, so I'm so sorry guys, this will not this is will not becomes, because x plus 1 becomes outside, then derivative of x is 1, so minus, and then x becomes outside, then derivative of x plus 1 is 1, so we will have x is 1.3 plus 1 and minus x is 1.3, so this will again not, this is wrong, so we will have 2.3 minus 1.3, so we will get 1 by 2.3 whole square, so we will get 0.118, so 0.18 here and 0.18 and 0.18 into 1.3, we will get 0.24, so by subtracting minus 0.56 we will get 0.31 plus. So next question, fx is equals to e to power minus x at e is equals to minus 0.1. So we will find the value of x, so minus 0.1 e to power minus, so we will put the value of x minus, and minus minus becomes plus here, so e to power exponential e to power 0.1, we will get 1.105, and f dash minus 0.1 becomes, first see the derivative of this, so minus x e to power minus x, then derivative of this becomes minus 1. Sorry, see the derivative of this, so derivative of e to power minus 1 becomes e to power minus 1, and dot derivative of this becomes minus 1, so we will have minus e to power minus x, so minus e to power minus x is plus, so we will put minus, and we will get this value minus 1.105. So now applying the linearization formula, Lx बराबर L f minus 0.1 plus f dash minus 0.1 and x minus minus, so put plus 1. So we'll have the value 1.105 plus another minus 1.105 x plus 0.1, so 1.105 minus 1.105x and minus, so minus 0.1, get minus 0.11, so minus 1.105, we have 0.99 and minus 1.105x, so this becomes answer. And we have the last question, and we have today's last question, so that the linearization of fx is equals to 1 plus x to power k at x is equals to 0 is linearization is equals to 1 plus kx. We have to prove this. So function we have fx is equals to 1 plus x to power k, so we have the value of x 0, so put x to power 0, so we will get 1, and the derivative of this we will get k bracket 1 plus x to power k minus 1, so we have put the value k bracket 1 plus 0 to power k minus 1, so it becomes 1 to power k minus 1, literally 1, so we will get k. So now using the linearization formula, we will get Lx is equals to f 0 plus f dash 0 x minus a. We have a here, a0, so put the 0. So we have value 1 plus k bracket x minus 0. So we will get 1 plus kx. So we have proved. So thank you this much. Please like, share with your friends, and please subscribe the channel and press the bell icon to get the more videos like this. Thank you.